student, good morning. We have already completed the chlorination of alkane examples. Mechanism was remain on that day, so we will continue the mechanism of chlorination of alkane. So how the mechanism is to be carried out? So already you know that what is meant by mechanism? The minute step involved in the chemical reaction is known as mechanism. Okay. So what are the steps involved in the chlorination of alkane? That we have to see. So in the mechanism of chlorination of alkane, there are three steps. First step is the chain initiation step. What is it called? Chain initiation step. How the chain initiation step is to be carried out? So see here, we know that in the chlorination of alkane, chlorine is the reagent. So in the first step, that is the chain initiation step. Chain initiation step. So this first step is called as chain initiation step. How is to be carried out? So first of all, we have, this is the chlorine molecule, right? Okay. When this chlorine molecule is exposed to the sunlight or ultraviolet light, exposed to the diffuse sunlight or ultraviolet light, so this chlorine is in a gaseous form, right? Okay. So this chlorine is in a gaseous form. So this gaseous chlorine, when exposed to the ultraviolet light or diffuse sunlight or by passing the photons or packets of bundles of photons h mu, what will happen? The bond between these chlorine atom, that is the covalent bond, and this covalent bond is formed by sharing a pair of electrons. So therefore this bond break homolytically and to produce the chlorine free radical. Okay, so this is the chlorine free radical. Okay, what is it called? It is called as chlorine free radical, right? Okay, as you have seen in the general organic chemistry topic, the intermediate free radical. So free radical is a odd electron species which is highly unstable. So that is the free radical species, the odd electron or unsaid electron species, okay, or unpaired electron species which is highly unstable is called as free radical. That intermediate you have seen in the first topic. So this is the first step. Now what is the second step? So this is the first step. So second step is the chain termination step. Okay, what is the second step? Second step is the chain termination step. Chain termination step. Okay, so what happened in the chain termination step? So here you will find that that is the that not chain termination step, that is the chain propagation step. That is the chain propagation step, right? Chain termination step is the third step, right? Okay, so the chain propagation step. So what happened in the chain propagation step? You know that in the chlorination of alkane, alkane is heated with the chlorine gas in the presence of ultraviolet light or diffuse sunlight produce the methyl chloride. So in the first step, this chlorine free radical is produced. This chlorine free radical attack on the hydrogen of methane. So we have, this is the methane, right? Okay, so this is the methane. Then what we have? We have the chlorine free radical which is obtained in the first step. So this chlorine free radical abstract the proton. Okay, so therefore this chlorine free radical abstract the free radical of hydrogen from the methane. So how it is takes place? So this bond get homolytically break. This is the covalent bond. Covalent bond get symmetrically break or homolytically break. So due to the homolysis, what happen? There is a formation of methyl free radical and hydrogen free radical. So therefore what happen? So this hydrogen free radical combine with the chlorine free radical, right? So what will happen? So this methyl free radical is as it is. Okay, so this is the methyl free radical. So this bond get break homolytically to produce the methyl free radical. So this hydrogen free radical and this chlorine free radical get combined to form the hydrochloric acid. So therefore this is called as methyl free radical, right? So this is the methyl free radical. So in the chain propagation step, methyl free radical is produced. In the chain initiation step, who initiated the reaction? Chlorine free radical is initiated. So this is the first step, this is the second step. Okay, so now what happened actually? This methyl free radical is there. This methyl free radical again combine with the second molecule of chlorine free radical. So this is the methyl free radical. Okay, so this methyl free radical again combine with the chlorine second molecule. So this is the second molecule of chlorine. Already we have taken the first molecule of chlorine here. Okay, so first molecule of chlorine produce the chlorine free radical, right? So this chlorine free radical abstract the hydrogen free radical from the methane substrate molecule and to produce the methyl free radical and hydrochloric acid. So now what happened? So this methyl free radical which is formed in the chain propagation step, it's again reacted with the second molecule of chlorine. So what will happen if it is reacted with the second molecule of chlorine? So therefore this bond again break homolytically to produce the chlorine free radical. So this methyl free radical and this chlorine free radical get combined to form the again methyl chloride, right? Okay, and the chlorine free radical. So this is the methyl chloride, right? Okay, and the chlorine free radical is there. So this is called as the chain propagation step. Okay, so what happened in the chain propagation? Have you understood? Right. Okay, so last step is the chain termination step. Okay, so already here I have given you how the chain termination step is to be carried out. Okay, so this is the third step, that is called as chain termination step. What happened in the chain termination step? Actually, you know that this chlorine free radical is produced, right? So in the reaction mixture, what happened? There may be the possibility of chlorine free radical get combined to form the chlorine molecule. So this chlorine free radical get combined to form the chlorine molecule. Similarly, so here in the chain propagation step, there is a formation of methyl free radical. There may be the combination of two methyl free radical to form the ethane. Okay, so in the third step, what happened in the chain termination step? There may be the combination of methyl free radical and chlorine free radical, because all these reactions are the chain reaction and they are taking place in the reaction mixture. So therefore, there may be the possibility of these combination of free radical takes place in the reaction mixture. So this chlorine free radical combine to form the chlorine molecule, methyl free radical combine to form the ethane, methyl free radical and this chlorine free radical may be combined to form the methyl chloride, right? Okay, so these are the three steps which takes place in the mechanism of chlorination of alkane. So keep in mind, how many mechanisms step of chlorination of alkane are there? 3 steps are there. What are that? First is the chain initiation step. What happened in the chain initiation step? Chlorine molecule get homolytically break. Okay, homolysis of this chlorine molecule to form the chlorine free radical. This is in the chain initiation step. Second step is the chain propagation step. What happens in the chain propagation step? Chlorine free radical abstract the hydrogen free radical from the methane. Okay, so therefore to form the methyl free radical, then this methyl free radical may become again react with the second molecule of chlorine, and there is a formation of methyl chloride and chlorine free radical. Right, this is the chain propagation step. Now what happened in the chain termination step? So there may be the possibility of chlorine-chlorine combination to form the chlorine molecule, methyl free radical to form the ethane, then methyl free radical and chlorine free radical to form the methyl chloride. So this is the mechanism of chlorination of alkane. Okay, so in this mechanism you observe that the chlorine as well as methyl free radicals are to be produced. Hence the mechanism is called as a free radical mechanism of chlorination of alkane. So already I told you that there are three types of mechanism: ionic mechanism, free radical mechanism and concerted mechanism. So therefore chlorination of alkane mechanism is a type of free radical mechanism. Right, okay. So this is regarding the mechanism of chlorination of alkane. So let us take one or two examples. Suppose I have this compound CH3, CH3, CH3H. Okay, so this is the alkane. Right, okay. What is the name of this alkane? This is called as isobutane. Right, okay. So this is the isobutane. Now I want to carried out the chlorination of this compound, right? Okay, so this isobutane is heated with the chlorine in the presence of ultraviolet light. Okay, so therefore you know that if such an example is given, the chlorination as well as bromination as well as iodination is there. So for that process, what you have to keep in mind, when you are going to complete the chlorination, bromination or iodination, you should know the order of reactivity of hydrogen atom. What is the order of reactivity of hydrogen atom? Already I told you, tertiary hydrogen atom is more easily replaced than that of the secondary hydrogen atom than that of the primary hydrogen atom. This is the order of replacement of hydrogen atom. The easy of replacement of hydrogen is tertiary, then the secondary, then the primary. So yes, once you know this hint, you can solve the problem easily. So what is the substrate given here? Alkane as a isobutane. Right, okay. IUPAC name is 2-methyl-propane. Okay, right. This is called as the 2-methyl-propane. So this is the isobutane compound. This is to be chlorinated. What we have? We have this order. So according to this order of reactivity of or replacement of hydrogen, so observe which type of hydrogens are present in the isobutane. So this is the primary carbon, hydrogen are present are primary hydrogen, primary carbon, primary hydrogen, primary carbon, primary hydrogen. This carbon is the tertiary carbon. So this tertiary carbon, why? Because carbon atom is attached to 3 other carbon atom. Okay, so therefore this is the tertiary carbon, 1, 2, 3. So these are the 3 carbon atoms are attached by this carbon. So therefore this is a tertiary carbon. So hydrogen atom attached to tertiary carbon is called as tertiary hydrogen atom. Right, so you know that tertiary hydrogen is easily replaced. So therefore this chlorine and this hydrogen, they comes out in the form of HCl. So what you will have? You will have, so this is the tertiary butyl chloride. Right, so HCl is the byproduct. This is called as tertiary butyl chloride. Why it is called as tertiary butyl chloride? Because this group is the tertiary butyl group and halide is, that is chloride. So therefore name will be tertiary butyl chloride. So write the IUPAC name of this compound. How we can write the IUPAC name of this compound? Select the longest continuous chain of the carbon atom containing the halogen atom. So you can start the numbering from this carbon or this or this. Suppose I have started from here 1 2 3 1 2 3 or from 1 2 3. You can start any one of the carbon atom numbering. So straight chain carbon will be of 3 carbon atoms. So therefore this is called a tertiary butyl chloride. So at 2 carbon atom, which halogen is there? Chlorine is there. So this is called as 2 chloro. 3 carbon atoms are there. So therefore name will be 2 chloropropane. Okay, but at methyl group is present at 2 position. So therefore one more thing is there. So first you write the name of the functional group 2 chloro, and then this is the 2 chloro, and at second carbon atom methyl group is there. So 2 chloro 2 methyl propane. This is the IUPAC name. Right. Okay. So what is the IUPAC name of this compound? 2 chloro 2 methyl propane. So from the 2 methyl propane, what you will get? You will get the 2 chloro 2 methyl propane. Right. Okay. So you can solve these such type of questions for the chlorination of alkane. Suppose you have taken the N-butane, then what will happen? Suppose we have the N-butane. So CH3, CH2, so this is the CH2 and this CH3. Then whenever you will ask to chlorinate or to carry out the chlorination process, so you have to first keep in mind that order of reactivity of the hydrogen. So see, how many type of hydrogen are there? So this is primary carbon, primary hydrogen, primary carbon, primary hydrogen, secondary carbon, secondary hydrogen, secondary carbon, secondary hydrogen. So which hydrogen is easily replaced? Secondary. So therefore you can replace this hydrogen atom easily. Okay. So therefore this hydrogen is replaced and chlorine atom is attached. There is a formation of 2 chlorobutane. Okay. So this is regarding the chlorination of alkane. Okay. So there are 4 type of halogenation of alkane. Already I told you: chlorination of alkane, bromination of alkane, iodination of alkane, and fluorination of alkane. So chlorination of alkane is over. So now next is the bromination of alkane. Right. So we can see the MCQ examples after finishing the halogenation of alkane whole concept. Right. So therefore I have not taken here the MCQ examples. So next is the second is the bromination of alkane. Bromination of alkane. Okay. So when you carried out the halogenation of alkane, we should consider the 2 MCQ hints. First this one, and second one is the order of reactivity of halogen is fluorine is more reactive than chlorine, than bromine, than iodine. Right. So these are the 2 hints for the consideration of halogenation of alkane. So this is the order of reactivity of halogen. Which halogen atom is fastest reactive? So fastest reactive halogen is the fluorine, then the chlorine, then the bromine, then the iodine. So this is the order of reactivity of halogens. Right. Okay. So keeping these 2 things in your mind, we can study the halogenation of alkane. So next is the bromination of alkane. What do you mean by bromination of alkane? What is general reaction and what are examples? That we will see. So see here. This is the alkane. This is the representative formula of alkane, RH. Okay. So when this alkane is reacted with the bromine, right? Okay, so this is the bromine. So bromine is in a liquid form, chlorine is in a gaseous form, right? So this liquid bromine is passed through this alkane. So this is the excess of alkane. This alkane is excess. Which one is excess taken? In the reaction mixture, alkane is taken excess. Then add this liquid bromine, and this mixture is to be heated in the presence of catalyst aluminium tribromide, AlBr3. What is the name of this catalyst? Aluminium tribromide. So this is the catalyst, AlBr3. So this mixture is when heated, then this is again a free radical reaction. So hydrogen free radical get replaced by the bromine. So this is a free radical substitution reaction or free radical replacement reaction. So hydrogen atom is replaced by the bromine. So therefore what you will get? You will get the alkyl bromide plus hydrobromic acid. So this is the alkyl bromide, right, or it is also called as bromoalkane, right. Okay, so this is the main product of the bromination of alkyl. What is the main product? Alkyl bromide or bromoalkane. So this is a type of simply free radical substitution reaction. This type of reaction is the free radical substitution reaction. Why it is called as free radical substitution reaction? Because hydrogen free radical is substituted by the bromine free radical. So this hydrogen free radical is substituted by the bromine free radical, or hydrogen free radical is replaced by the bromine free radical. So therefore this is called as the replacement reaction. Okay, free radical replacement reaction or free radical substitution reaction. So you know the type of reaction, free radical substitution reaction. Okay, so now examples, let us take the examples. Okay, so first example of alkane, that is the methane. Okay, so let us take the excess of methane. So when this excess of methane is heated with the bromine, right. Okay, so we have, this is the bromine molecule, right. Okay, so when this excess of methane is heated with the bromine in the presence of AlBr3 catalyst, aluminium tribromide catalyst. So this is the reactant, that is both the reactant excess of methane and this bromine. This is act as the substrate molecule, this is act as a reagent molecule, right. Okay, so when this excess of methane is heated with bromine liquid in the presence of AlBr3 catalyst, then this is act as a catalyst, you can write. Okay, so this is a catalyst. So which catalyst is used in the bromination reaction? Aluminium tribromide, AlBr3. Okay, so as we know that the hydrogen atom is to be substituted or replaced by the bromine. So therefore what you will get? You will get the methyl bromide and hydrobromic acid. So this is the methyl bromide. IUPAC name bromomethane, right. Okay, so bromomethane is the product. So in board exam question may be asked like this: how will you prepare bromomethane from methane? So if the question will ask like this, first you have to write the theoretical part. How you write the theory? When excess of methane is heated with bromine liquid in the presence of AlBr3 catalyst, undergoes free radical substitution reaction to form methyl bromide or bromomethane. This is the theoretical part, and after writing the theoretical part you have to write the reaction. Okay, so this is the reaction, right. This is the first example. Now let us take another example. Okay, I will take the another example. So another example is of this ethane. Okay, so when this excess of ethane, right. Okay, so this is the excess of ethane. Excess of ethane is heated with the bromine in the presence of AlBr3 catalyst. Okay, so therefore what will happen? There is a replacement reaction. Again this hydrogen atom and this bromine, they comes out in the form of HBr. So what will be the product? So product will be, so this is the CH3, CH2 and bromine plus byproduct is HBr. Right, okay. So this is called as ethyl bromide. What is the common name? Ethyl bromide. First write the name of the alkyl group and then put the word halide, ethyl bromide. IUPAC name is bromoethane. So this is the bromoethane. Right, okay. So there is no any complicated part in these two examples. Right, okay. But suppose the propane is to be reacted with the bromine, what will happen? So this is the second example. Okay, so now I am going to take the third example. Right, so I will wipe out this example. Okay, so you can easily understand. Right, okay. So this is the excess of ethane. So suppose I want to take the excess of propane. Right, okay. Suppose this is the instead of this excess of ethane, excess of propane. Excess of propane. Right, okay. So this is the excess of propane. So when this excess of propane is heated with the bromine in the presence of AlBr3 catalyst. So how to solve such a questions? So keep in mind, whenever you complete the reactions of bromination of alkane or chlorination of alkane, you have to understood this trick. What is the trick? Order of replacement of hydrogen atom. So what is the order of replacement of hydrogen atom? Tertiary hydrogen easily replaced than secondary than primary. Right, okay. So tertiary hydrogen is easily replaced. So first of all, identify the nature of hydrogen atom. So this carbon atom is primary carbon, attached hydrogen is primary hydrogen, this is the secondary carbon, the carbon atom which is attached to two other carbon atoms, so therefore this is the secondary carbon. Okay, so therefore two hydrogen atoms are attached, so therefore this carbon is the primary carbon which is attached to only one other carbon atom. This carbon atom is attached to the other two carbon atom. So therefore this is this secondary carbon atom. Right, okay. Then what we have, primary hydrogen and we have the secondary hydrogen in this example. In this example, there are two type of hydrogen, primary and secondary hydrogen. So which hydrogen is easily replaced? Secondary hydrogen is easily replaced. So you have to replace the secondary hydrogen atom, not the primary hydrogen atom, because we have given this order. So therefore this secondary hydrogen and this bromine, they comes out in the form of HBr. So what will be the product? So CH3 is as it is. So this is the hydrogen. So bromine is attached. So this is the CH3. Right, okay. Then what is the name of this compound? This is called as secondary propyl bromide. 2-bromopropane is the IUPAC name. Right, so 1, 2, 3. At second carbon atom, bromine is there. So therefore, how to write the IUPAC name? First write the name of the functional group, bromo. Bromo is present at which carbon? 2. So it should be written before the bromo. 2. This is the hyphen. Then how many carbon atom in the straight chain? 3. So propane. 2-bromopropane. It is also called as the isopropyl bromide. Okay. So you have to solve the questions like this. Okay, so this is the excess of propane give the secondary propyl bromide, that is the 2-bromopropane. Okay, so this is the bromination of alkane. So you can take the another example, N-butane, isobutane, N-pentane, isopentane, neopentane. So you solve and you do this practice, right? Okay, so I want to take the MCQ example of this bromination of alkane as well as chlorination of alkane. Right, okay. So suppose I have the two examples of MCQ like this. Identify, suppose the question is like this. Identify A in the following reaction. A in the following reaction. Okay, so suppose question is like this, and if the reaction is given, so reaction is given as such. So this is the CH3, 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 CH3. This is called as neopentane. Right, okay, so this is called as the neopentane. So how this neopentane is to be chlorinated or brominated, that we will see in the next video. Thank you.